This is exercise 9E and I'm going to go through question 11. So it says a particle is projected vertically upwards from a point O with speed u. So we're not sure exactly, but the initial speed they've just given us the letter of u. 2 seconds later it's still moving upwards and its speed is 1/3 u meters per second. And the first part is to find the value of u. So I'm just going to do a very quick sketch of what we've got here. So this is exercise 9E. Question 11. So we've got this particle and first it's projected upwards with a speed of u and it moves upwards, and then 2 seconds later it's still moving upwards, but this time with a speed of u over 3, or 1/3 u. And we want to work out the value of u. So let's just write what we know. So we've got our normal SUVAT letters out, and because both these speeds are upwards, I'm going to take upwards as the positive direction, and it's really important that you state which direction you are taking as the positive direction, like I've done here. On lots of people's homeworks, they hadn't stated the direction, and that leads to quite a lot of confusion about which signs you need to use. So if you state really clearly which one is your positive direction, it leads to less confusion and it's clearer what you need to do. So we know that the initial speed was speed u, and it was upwards, so I can keep it as a nice positive u meters per second. The final speed, well, we're talking about 2 seconds later, we're going to say that is the final velocity, u over 3 meters per second. The acceleration, well, I know that we're talking about gravity here, it's vertical motion. Gravity acts downwards, 9.8. So because I've taken positive as being upwards direction, therefore the acceleration is negative 9.8 meters per second squared. And the time is 2 seconds. That's what they said in the question, that 2 seconds later. And so I want to work out what this value of u is. So I'm looking for the formula that involves u, v, a, and t. And that formula is the first one, v equals u plus at. So let's sub in what we know. We know u over 3 is what v is. U, well, I'm just going to use the letter u for that, plus 9.8, negative 9.8, sorry, times t, which is 2. So negative 9.8 times 2. And so I'm going to, what shall I do? I'm going to take u over 3 onto that side, so I get that 9.8 times 2 is equal to, well, u take away 1/3 of u is going to be 2/3 of u. And then I can divide this side by 2/3. So I'm doing, just to be clear exactly what I'm doing here, I'm going to do 9.8 multiplied by 2, and then I'm going to divide that by 2/3. To find my answer for u. So u is equal to 29.4 meters per second. Then part B of question 11, it says find the time from the instant the particle leaves O to the instant it returns to O. So let's write out what we know. We're talking about the total time this time. Lots of times there. So I'm going to write out the letters again. This time t is what I'm trying to find out. I'm going to put a question mark there. I'm going to take upwards as being positive again. And so therefore the acceleration is going to be negative 9.8 meters per second squared again. V I don't really know, although I kind of know because of symmetry, but I don't need to use V in this one. U is what we've just worked out, so 29.4 meters per second, and it is upwards, so that's nice and positive, that's fine. And S is going to be 0, because if it's going from its start position to where it ends up back at O, then the displacement is 0 meters. So I'm looking for time, and I've got S, U, and A, so I'm going to use S equals UT plus 1/2 AT squared. Now I know S is 0, so I've got 29.4T plus 1/2, but negative because it's minus 9.8 T squared. And if I rearrange for that, I will get 29.4 T is equal to 9.8 over 2 T squared. And then I can just say, well, T is going to be equal to 29.4 divided by, sorry, skip myself ahead here, 9.8 over 2. Just checking I've not skipped that bit too quickly for you. All I've done is cancelled one of the t's out each side and then divided by 9.8 over 2. So I've got 29.4, not sure you can see this very clearly, divided by 9.8 over 2. And so the time is 6 seconds is what it takes to get to the end. So we've got the time to return to the original position was 6 seconds, and for that first one we got that u was equal to 29.4 meters per second.